Hi guys, welcome to my YouTube channel. Today I'm going to talk about copy move elision in C++ and explain in details that what is exactly copy move elision. And the contents of this video is based on the CS246E course, Object-Oriented Programming Advanced in the University of Waterloo. And I hope you all enjoy this video. If you'd like to see more videos about the Object-Oriented Programming course or Math 249 course that I put the videos on them and I create videos on them. And please let me know in the comments. And please like the video if you enjoy these types of videos. So let's go into it. So we have our class C, which is a very basic class. It has a constructor, copy constructor, and move constructor. This is the move constructor, this is the copy constructor, and this is the main constructor. And I put the C out to see which one exactly is running inside the terminal when I run the program. And the experiment we are going to make is that here we have a variable experiment of type C, and we are calling the constructor. So what we expect is that the constructor for the object C runs and then creates a temporary object and then use either copy or move. I'll explain which one later, but now assume that we don't know which one. Copy move constructors to put our data inside the experiment variable. So let's not talk too much and run the program to see exactly what happens, and then I will come back and explain why that happens. So let's compile with C++14 and see what will happen. Wait a sec. The constructor runs, but none of the copy or move constructor runs. We clearly have an assignment operation here. So why none of them actually runs? So the result was none of the copy move constructors run. But why? Well, this phenomenon is called copy move elision. And actually it is not related to our code, it is related to the compiler. The reason is that the compiler is allowed to skip copy or move constructors in some circumstances. And what does that circumstances means is that compilers in today's world are really smart. So it knows that this object C is going to create a temporary object and then copies it inside the experiment variable, which is not exactly what we want. So it knows that its final destination is the experiment variable, and we are not going to use that temporary object anymore. So it skips the copy move constructor and it goes and directly creates the object inside the experiment variable. So it avoids that temporary object. But the question is, can we stop that? It's not related to our code, so there's nothing to do here. But the answer is yes, we can. Stop this and avoid compiler from doing copy move elision in the compile time. And the tag we need to use to avoid compiler from doing it is -f_no elide constructors. So let's see what will happen when we add this tag. So we add -f_no elide constructors. And let's see what will happen if we run it now. Perfect. Now we can see move constructor runs. When we run the program with this tag, we can see that the move constructor runs. The reason that the move constructor is running, not the copy constructor, is that that temporary object doesn't really have a place inside the memory, and it's not counted as an L value, it's counted as an R value. And the R value, the constructor that's going to run for an R value is usually a move constructor. And this is it is very similar when you call a function that returns an object C. So it's like a function that's returning a temporary object, which is not an L value because it does not have a place. It's not inside the memory. It's an R value, and it's going to use the move constructor to put the value inside an experiment, a value. While I was compiling the code, I noticed something. I don't know that you guys also noticed that or not. In my usual videos, I used C++17. But here, when I compiled the code, I used C++14. So I made that mistake, and let's just change it C++14 to C++17. Because when I took this course, we were using C++14 in that course, and that's the reason. Wait. That was not a mistake. The actual result is different. We can see here that when I run it with C++14, the constructor runs and move constructor runs as well. And I have this dash f no elite constructors as well here. But when I run it with C++17, still having that tag, where is my move constructor? So the question is, wait, in C++17, where is my move constructor? Well, the answer is simple. From C++17 onwards, means C++20, 23, and keep going, the copy move elision is mandatory. And even if you add that tag, the fNoElite constructor, since it is mandatory, it's not going to make any difference. And the compiler is still forced to skip both copy and move constructors, and you can't stop it anymore inside the code, and the compiler will do it. So if you want to really stop it, you can use stdmove. But that's not the purpose of this video, because I haven't talked about the stdmove yet. When I talk about it inside another video, you will see that this stdmove will force the move action, because it's not actually decided based on this. The compiler isn't going to just skip your stdmove, and it's going to run the stdmove. But if you just follow the normal routine, it's the compiler from C++17 is going to skip both copy and move constructors, and this is what is known as copy move elision. And I hope you enjoyed this video. This is the end of the video. I talked about the copy move elision, and that's it. Hope to see you soon in my next videos.